Person, and today another science video, and it's not about corrosion this time. Actually, not. It's about today's episode. I wanna talk about scanning electron microscopes, because guess what? That's another exam that I need to take. So, I thought that maybe I could talk about that. Let's see. I didn't find my wireless mouse, so here's a wired mouse. So I'm gonna talk about scanning electron microscopes, and why not talk about it in Blender? And later GIMP, and then later Blender again. So let's see. Delete this part. So I think I will talk about it through like the stages of where the electron beam goes. So electron beam is just a beam of electrons. Simple as that. So electrons electrons and photons sorry about that. Electrons and photons, they share a little bit of properties. So yay, quantum physics. I won't go far into that because I don't really know that much about it, but I know a bit. So electrons and photons, they share some properties. Both are in a kind of limbo where they are both particles and waves, and neither at the same time. Like, they have some major identity crisis or something. They do not know what they are. And yeah, so they are something. If that is allowed to say they are something, but at least so they are like beams, almost like they are beams of light, but of course it's not light, it's electrons. They have a wavelength, and they also behave a bit like particles. So yes, it is weird. It is. So, but yeah, so we follow the electron beam through the microscope. So let's begin with modeling here. So first I wanna begin with just like making a very bad 3D model of the electron gun. So one thing I could say about the electron microscopes is that they are quite similar to the CRT TVs. So the CRT TVs, they have much of the same, but a bit simpler technology. So in a electron microscope, both transmission and scanning, there are like multiple lenses, and in CRT TV it's only like a couple of lenses, but and the lenses is to make like they have to focus on like points on a quite big surface, so like they make scanning lines. Actually, you know what? I think I will talk about that later, but they are similar, but they make scanning lines and those scanning lines like illuminate a phosphorus or something surface that we call a screen. Okay, so this is explanation for black and white CRT TVs and not the colorful ones. So like explanation for like really old-fashioned, but technology should more or less be the same. But anyway, back to microscopes in our TVs. Yeah, so I'm modeling here. Let's see, which one should I? That one, yeah, that one. Cool. So I'm here modeling the filament. So the one part of the electron gun that that produces the electrons. So this here is quite powerful cathode. So traditionally the first ones, the ones in the microscopes in 1950s and yeah, maybe later, just 1970s or something. I don't remember the dates now, but the first one, they were of tungstens. So the W on the periodic table. And later one changed it to lanthanum hexaborate crystal, or LIB6, lab6. Later again one changed it to field emission source, whatever that is. So that is a cathode. So this here will send out some power. So the electrons are generated there. Further down the line, let's add, what should we add here? Yeah, let's add that Thoris, because I think that kind of illustrates this the best. Let's rotate. No. Let's rotate it around the y-axis 90 degrees. So I hear this very quickly. It becomes a blended tutorial of all things. But that's not bad. You know, let's say from front, not front. Yeah, actually front. Front is good. And let's see. I have a plan. Good to know. I have a plan here. No, I don't. Okay, so view from right, I guess. Okay. Or if I do this, yeah, I can do this. I need a better tutorial myself. So let's see if I can do this here. So put on this is okay. So yeah. So this is gonna be so let's see how this looks in not wireframe. I mean, looks kind of cool. So so let's look from. Okay, so we're here. It's kind of a lot of let's look at. I'm gonna annotate a little bit. So this is then the anode. So let's just annotate this is the cathode. Yeah, badly written, but something. This is the something. I hope you can read it. Anode. It should be written at least. So what happens between these two? So so this is like very negative. This here is quite positive. And why is that? That's because between these two, yeah, I have notes. Sorry, no, not sorry. It's actually good to have notes. So this is like a symbol for something generating voltage, or really battery symbol, and it's not battery. It's I would be impressed if you have battery for this. So between these two, you have like a quite powerful voltage, quite high voltage. So we are talking thousands of volts. So 20,000 volts. That's totally not unrealistic. You could actually go up to like 50,000 volts, but I'm just gonna write like 20. That's about 20. We need a better. Oh, that doesn't look so bad. Like I'm writing with like a mouse, and I'm impressed by myself right now. So it's like 20,000 volts between those two. So this will mean that the electrons E minus, they're like accelerated quite much between these two. So really, it wants to hit this thing, as this is positive. Okay, I see that will become, so it wants to hit this thing. But a selection of these, you probably from top again. Also many will hit there, some hit there of the electrons. It wants to hit. It really wants to hit this. Really. But some go through. Some just like misses this thing. So they go through this thing, and because they do this, so these are the electrons we are interested in. These are the electrons. Like all this effort was to make these, so that they could like fly away in incredibly high speeds. Actually, very fast, just pyong. So yeah, so further down the line, you will have some, not one lens, several lenses down the line, and then you will like make a scanning grid on a small object, and then register the results of that later. So I'm just gonna like save it, and let's see you in GIMP. Okay, so now we are in GIMP, and I'm gonna like draw. What else do I need GIMP for besides drawing? So what we like have here, it's maybe I should draw it the other way. Maybe I should put up the force quite a bit. There we are. Okay, so let's say we put it this way. And it looks not so good, but it could look good enough. Whatever. Say, maybe not the rest my. This is oh, it actually displays quite well where the mouse is. That's actually very good. So what I'm drawing now is the electron lenses or magnet lenses or whatever you wanna call them. So here is like magnet, electromagnet really, and here is like it's surrounded by iron. So this is really to strengthen the magnets, who are like way strong already. So this surrounds this, you know, like surrounds the path of the electron beam. So this is torus shaped or donut shaped, if you wanted magnet donuts. Well, that does really not sound that tempting. So these are very powerful magnets. So to the electrons, this more or less acts as optical lenses to the light. So let's say we have okay, so this will, I'm just finding the middle here. So we okay, let's see. I think maybe I should see if I can make paths here. One 2-point paths, but too bad. Okay, so stroke paths, stroke. Oh no, that I don't like that. Not pattern. Why is it always unpatterned? It's not a pattern I want. Stroke. So this is done. So let's say just a little mark here. So just drawing. No. Here, I think. No. It should. Why is this a thing? Okay, in this part, I don't like GIMP. If that's allowed to say. Why can't I hit? There. Good enough. Stroke path. Solid color. Bam. Okay, just now the GIMP was actually a bit annoying. From there to there, let's say. Stroke path, stroke. I guess this is also turning into a GIMP tutorial of all things. And instead of like explaining, you know, science, it's become a GIMP episode, a Blender episode on how to make things in GIMP and Blender. Why do I miss? There. Good enough. I don't have control, do I? Okay. Good enough for now. So, as you can see here, so naturally this is more or less spreading, and we can't have that. So, and we need this to become smaller. So, okay, I see here in reality in this sketch it didn't become smaller, but let's pretend it became smaller. And so the lines are spreading like this, beams are spreading a little bit. The magnets, it affects moving electrons, and this is definitely moving. And by how the magnet is shaped, it moves all the electrons towards the center. So this is what is happening here. They have like a force. They have like a force to move them towards like the center here. Magnetic force, one of the well, the magnetic force is one of the 4 fundamental forces. Well, it is within the electromagnetic force. So, well, they found out that the electric force and the magnetic force is the same, is 2 sides of the same thing. But, well, that's complicated. I'm just going to talk about magnetic forces. Yeah. But either way, these wants those to go like towards middle here, and depending on the distances here, this might get bigger than it was or smaller than it was. And here it was supposed to get smaller, but I think actually it's bigger, but please ignore that. So, and also this corrects, it concentrates it. So let's say that you like again has a magnet beam here, and it's like, and it makes it even smaller, and maybe you have like, and then you later have a kind of a lens that is like kind of special lens that it makes the electrons like it's very pointed sharp at this point, and it points the electrons at different places on the very small object. So just like on the TV, maybe I can just show it here. So just, or maybe under is better. Under, yeah, like Narnia, under me, but under here. So this makes like raster pattern like this. So where the beam points on, just for clarity, that the magnet, so there's like how the magnet points, so it goes down this line, points down this line, goes down there. So it controls both in the let's just for conventional just call it X and Y, just to have something to like directions to talk about. So really X and Y, if they are like 90 degrees from each other, you can pretty much often define them, and now I'm just gonna define them like this. So so it goes in a direction X, goes down X, goes down among Y as X is decreasing, increases in X, decreases in X, increases in Y, and it goes like it goes like this down the line. And of course it doesn't really send beams there, so just like a TV. So on a TV, like if you got like a high voltage here, you got like a bright light here, and you have a white dot on your screen. Like just random rambling.